Okay, so guys, let us start with the course. As we know, this is a day 2 of data science fast track course, and this is Nawaz. I am a corporate trainer, consultant, and mentor, and this is about me as we already discussed about this. So let's go ahead with the agenda of today's session. And in the today's session, you will find that we will going to work with the data frames by using Pandas library. As we know, Pandas is one of the most popular library in Python, and we are using that library for creating the data frame and how you can handle the data frames in by using Pandas in Python. Okay, then second thing is that, okay, we will be working on data cleaning and data pre-processing. Okay, I'll show you how you can clean your data and how you can pre-process your data. Both the things are similar. Okay, now third thing is that we'll be exploring some data visualization like the bar plot, scatter plot, histogram, box plot, violin plot, pie chart, like this, by using Matplotlib library in Python. Then, okay, these first three topics are nothing but the practical thing. Okay, we'll use Python for this Anaconda as we used yesterday. The same tool we are using today as well for you know doing this first three topic. Then after this, okay, we'll move to the fourth topic, which is nothing but basic statistical concepts. So from here you will see that some theoretical part is there, but again it's very interesting and it's very important for our upcoming sessions of machine learning and all, right? So we'll be talking about basic statistical concepts like the measure of scale. Different scales are there, like the what are the different types of random variables, different types of sampling methods, confidence interval is there. Then we'll be talking about descriptive statistics. In the descriptive statistics, we'll be talking about the mean, median, mode kind of thing, right? Then we'll move to the probability concepts. So here we'll be talking about the probability, and along with that we'll be talking about the different probability distribution. As we know, there are two different kinds of probability distribution. First one is discrete probability distribution, and second one is the continuous probability distribution. So we'll be talking about these things as well. Then we'll try to explain different sampling techniques. What are the different sampling techniques we are gonna use in our upcoming analysis, upcoming projects, as well as the confidence interval. Okay, and lastly we'll be talking about the hypothesis testing in this particular session. So guys, let's get started with our practical part. Okay, let me just open Jupyter notebook. Okay, you can also open your Jupyter notebook and we'll start running the code. So this is my new Jupyter notebook. Let me rename this day 2. Okay, now code. As we know guys, yesterday we saw the few data types in Python. And what are those? Okay, we saw the numerical data types like the integer, float, right? Then we saw the string value, right? So these many data types we saw. Now let's quickly overlook on the list, tuple, dictionary. Okay, and then we'll go with our agenda of the today's session, like the data frames in Pandas, how you can create the data frame in Pandas. So let's talk about the list. So here you can see that, okay, you can create the numerical list like this. Okay, like L1 is nothing but the numerical list, and this is nothing but the output. Okay, in the same way you can create the the list 2, which is again let's say the string list, right? This is my mm, let's say 56, 32. Okay, you can even go with the 1.23 value as well. Okay, then L3. Okay, so here you can see that this thing. Yeah, so you can create list is, in short we can say that list is nothing but the collection of anything. Okay, you can collect the text data, you can collect the numerical data, you can collect the mixed data as well. Okay, now here, okay, if you're talking about the list, okay, this is how you can create the list. Now the second thing is that, as we saw the slicing, okay, as we saw the slicing in the previous session, okay, so here also you can use the slicing. Okay, now let me show you how you can use the slicing over here. Okay, so here you can see that, okay, let me create, okay, let me take this any one of this, let's say, let me take the list 3 L3, and I'll be just now doing the slicing. Okay, as we know guys, how we can do the slicing, just we can use the name of the list, as we have used the name of the string in the previous session. In the same way, as we are just taking the name of the list, and in the square brackets we are just mentioning the index number of elements. Okay, like this thing. Okay, if let's say if I just wanted to take the all the elements from 0 index to, let's say, second index, and I want the output. So here you can see, so this is a 0 index value, this is a first index value, and as we know, second index is excluded, so we'll get only two values. Understood? In the same way, if you wanted to go ahead with the this thing, okay, the, let's say, 2 colon and enter it, shift plus enter means execute this particular cell, so you will see that the, okay, you will get these many values or these many entries of the list. Okay, in the same way, if you wanted to go ahead with the slicing, okay, to the end, so here you can see that, okay, this is nothing but the slicing from the start, and this is going to be the slicing to the end, right? And this is a, this is a, you can use any index number like this, and you can take that particular sub part of the list, right? Now here also you can use the negative index, as we use the negative index in the you know string as well. So here you go. Okay, see, this is how you can use the negative index. In the same way, you can use the negative index at the beginning as well, or you can use the two negative index at the starting point and the ending point, right? So let us go further, okay, because these are the yesterday's part, so that's why we'll be shortly looking at this, because we saw yesterday as well this thing. Okay, now this is about the list. Okay, yes, so let me show you the one example for this, then you can tell me lists are mutable or immutable, right? So let me again take the L3 example, list 3. This is my list 3. Okay, see, and what I can do is, I just wanted to now update the value of one element of the list, right? So let me take this. Okay, I just wanted to change the value of 56. So as we know, index number of 56 is 2. Okay, and I just wanted to change 56 by, let's say, 1000. Okay, and let me enter it, and now let me see the list 3, and here you can see. Okay, now I am able to change this particular value. Okay, firstly, which is 56, now it is 1000. Okay, so we can say lists are mutable, right? Lists are mutable, isn't it? As we know, in the in string as well, we have some inbuilt methods. In list as well, you can use some inbuilt methods as well. Okay, and what are those methods? Like if you wanted to add some elements, so you can use the append method. Okay, like I'll be using the append method. See, and I just wanted to add a, let's say, value 12. Okay, so you will see that L3 now is going to be the new list with the last entry is 12, right? So we can able to append the list, we can able to add the elements in the list. Now second thing is that we can able to remove the elements from the list as well by using the pop, right? By using the pop. So if I use these, so I can simply enter this, okay, which means that, you know, I got this last entry which I remove. Now you can see the list 3. Okay, again my list 3 does not have this particular 12 value, right? Now if I wanted to, remove any particular index element, okay, let's say I just wanted to remove this Python. Okay, so what can I do? I can simply go ahead with this L3 dot pop, and I'll add the index value for Python and enter this. Now you can see Python is here, so you don't see Python in this particular list. Okay, right? So this is how you can go ahead. Now like this, okay, like you wanted to, you just add the, by using the append method, you just able to add the 12 value at the end of this, list. Now what if I say I just wanted to again add this Python, okay, okay, at the same index 1. So is there any method for this? Yes, there is a method which is nothing but the insert method. Okay, I just wanted to insert this Python at the first index. Okay, and let me run this and now see the L3. See, it's, we can able to, you know just add the Python word. Now the second thing is that, guys, we can, we can use the, del to remove or to drop all the list, right? So that's the method, and you will find that the in Python there are more than 2 methods for doing the same thing, right? If you wanted to, read the data, or let's say if you wanted to visualize the data, so you can use the Matplotlib library. If you wanted to, again visualize the data, you can use the Pandas library. Again, if you wanted to do the same thing, we can do the same thing by using the, you know Seaborn library, Plotly library, ggplot library. There is a one version of ggplot library in Python as well, right? So for doing same thing, there are multiple ways you can do that particular same thing, because of the Python is open source. Because of that reason, we can, stack is nothing but just adding the data, okay, row wise and column wise. Here you can see that the data is row wise, so we can be able to add the row wise data here by using the extend method. Okay, let's say there is a L3 list is there. Okay, see, L3 list is there and there is L2 list is there. Okay, I just wanted to add these two list. Okay, add this two list. Let's say I just wanted to, okay, add this L2 list in the L3. So I just wanted to add this element over here, okay, at the end of this. So what can I do? I can simply go ahead here and use the extend, okay, and simply L2, and here you can see, and now L3 is going to be the new list with the new elements A, B, C in the last. Okay, now guys, okay, let's go ahead, move ahead with the list. Okay, let's talk about the, you know the tuple, because you will find that there are so many different things you can do with the list. Okay, if you wanted to explore more about the list, okay, you can simply go ahead with this particular, you know python.org website. So with this particular website, you will be able to, explore, lot of things for this particular data type, which is nothing but list. Okay. Now let's go ahead with the tuple. Okay, because for this list as well, okay, for we need, at least 2 to 3 hours to explain all about the list. Okay. Now let's go ahead with the tuple. We are using the list to store multiple elements in a single variable. In the same way, we are using the tuples to store multiple variables in a single way, multiple items in a single variable, right? Yeah. And what is the difference between tuple and list? As we know, lists are mutable, so tuples are immutable, right? Tuples are immutable, so we can't, if we form the tuple, so you know we can't change the value of the tuple, right? We can't change the value of the tuple. Okay. Now, okay, like it contains no duplicate. Now let us go ahead and create the list, let's say L4. Okay, with the, let's say 1 2 3 4 4 4 5 6. Okay, now let's run this, and let's run this again. And here you can see that in my tuple there are two duplicates values. Okay, in my tuple there are two duplicates values. So yes, in tuple, is it possible to, write duplicate values? Okay. Now one more thing. Okay, let's quickly go ahead with this. Okay, let me create the tuple. Okay, let's say 1 2 3, right? 4. Let me create the again new tuple, y tuple. Let's say 5 6 7 8. Okay, and is it possible to, join this two tuple by using this? Yes, right? Yes. Okay, we can able to, update the tuple. Okay, but right, once we form the tuple, so we can't change the values inside that tuple, right? So that is the thing. Okay, you know the tuple is there, x tuple is there, y tuple is there. I can simply use the x delete tuple. So now let me check. Yes, we got the error. Why? Because we just deleted the tuple. Okay, and what is the, you know if I use the, pop method over here, okay, now you can simply check. Okay, you can simply use a pop method over here, and you can use this to remove particular value. Okay, and see whether it is possible or not. Let us go ahead, guys, and understand the further part of the tuple. Okay, and here you can see that, as we know, we are able to delete the, tuple by using the delete. Now second thing is that if we wanted to check, this is my y, okay, tuple. I just wanted to check the size of this. Okay, I can use a len function. Okay, and here you can go the, there are 4 values or elements, okay, inside the tuple. Okay, guys, this is a part of yesterday's session. Okay, I hope, okay, if you wanted to, again, now this is about the tuple. Now let us talk about the dictionary. Yes, absolutely, key value mapping is there. Okay, and dictionary is nothing but the collection of key value pairs, right? Right. And how you can create the dictionary? Let's say A is my dictionary, and how you can create the dictionary by using the curly brackets, isn't it? Okay, and inside the dictionary you will see that the keys, okay, the keys with the values, you can say, right? Go with any value, right? You can go with the name, you can go with the number, you can go with anything. Okay, so value 1. Okay, in the same way, let me use this. Okay, simply I can copy this thing. Okay, so here you can see key 2, key 3 is there. Okay, right? So this is my dictionary. See, this is my dictionary. Now, why to use dictionary, guys? Anyone? Why we are using dictionary? Anyone, guys? Why we are using dictionary? Yes, to store the information. But the main purpose of dictionary is to create the data frame. You can be able to create the data frame, right? Okay, let's say, right? So this is how you can, sorry, that's the thing. A2 is not defined, so that's why I got the error. I just wanted to use A1 instead of A2. Now here you can see that this is my dictionary. Now, one more thing, you can be able to, update the values. Okay, let's say I just wanted to update the value. Okay, update the age, let's say. Okay, so is it possible to update the age? Yes. Is it possible? Right? I just wanted to update the age from 25 to, let's say, now 26. Okay, so here you can see I'm able to update the age. So in the simple way, you can be able to update any feature, right? And if you wanted to add the few more features in it, okay, few more keys in it, like this is nothing but the one key, this is another key, this is the third key. In the same way, if you wanted to add the new key over here, so I can simply, okay, use the new key, let's say address. Okay, and I'll, let's say address is Delhi, India, right? So this is how I can add the address, right? See, so which means that you can be able to update the tuple. Okay, in the same way, if you wanted to, delete the particular element or particular key with their value, okay, so you can be able to do that. How? You can be able to just use this particular term. Okay, whatever key you wanna delete, let's say I just wanted to delete the name because for the purpose of confidentiality. Okay, so I just wanted to hide the identity, so I can use this. I can simply use the del. Okay, and I can simply enter it. Okay, now see, here you can go. Okay, now in my data there is no name. Okay, we only have age, bike, address. Okay, so we just hide the person's identity, right? Now if I wanted to delete the whole dictionary, so I can simply use this. Okay, and now let me check. Yes, we just deleted the dictionary. That's why there is no dictionary found with the name A1, because see, we just deleted it, right? Understood, guys? This is all about the dictionary, right? If you wanted to explore these all the thing, okay, so you can simply explore this thing by using the internet. Okay, and if you have any questions related to this, you can simply connect with me on LinkedIn. Okay, we'll definitely, okay, solve that particular query of yours. So now, guys, this is about the list, tuple, and dictionary. Okay, now let's go ahead with the data frame. Data frame, how you can create the data frame. Okay, using pandas library. So as we know guys, for okay, using pandas, you will have to import the pandas first. Okay, and how you can import the pandas, like each and every time. Okay, this is the word I don't want to use it, so instead of that I'll just add the you know PD instead of this. This is also known as a alias. Okay, in SQL also you saw this. Okay, if you wanted to okay, shorten your name, so you can simply use this. So we are using import pandas as PD. Okay, and you can simply use this. Now second thing is that, okay, now okay, there are multiple ways. Okay, like if you have the data already in your system, so you can simply use your data, and you can simply enter your data by using the, or read your data by using the read underscore CSV. I'll show you that as well, how you can read your data in Excel format, CSV format as well. Right now here, if you wanted to create a data frame by using pandas library, so let me show you how you can create the data frame. Let's say I just wanted to create a data. So for that I'll be using the pandas library. See, instead of pandas, now I'll be using PD. Okay, so remember PD is nothing but the pandas library we are using. Okay, I just wanted to create a data frame. So this is the one method, with the help of that we can be able to create a data frame. Okay, now inside the data frame, okay, you will have to add some values as well as the names for those values, which are nothing but the column names. Okay, so for that I'll be creating the dictionary inside the data frame. Okay, let's say I just wanted to you know uh, create the dictionary of name. Okay, and the age. Okay, so I'll take the few persons name from our from our list of attendees, and here you can see for that. Okay, now you can see that I just created the one column name. Okay, now if I just wanted to take a list of multiple students, so for that I'll have to create the list over here. Okay, let me enter the few name. Okay, let's take Chirag. Okay, now this is the first column we just created. Understood? Now if I just wanted to create the next column, so I can do this by adding the indentation over here. Like I just complete this, and I'll go with this. Okay, and I'll add the one more column name over here, which is nothing but the age. Okay, and let me now as I took the the names of the attendees, so I'll randomly put the age instead of taking the age from the attendees. So let's select the age like 24, 26, 23, 22. Okay, so as we know there are four names, so I'll have to add the four ages as well. Right, and let me enter it. Okay, now this cell is executed. Now if I wanted to see the data, now you can simply use the data. Okay, here you can be able to see this is my data. Okay, with the name and age. I just created a small data set which is totally random. Okay, you can also create the data set like this. Okay, by using the pandas library. Okay, now okay, what I just wanted to do is I just wanted to find out the descriptive statistics. Okay, I just wanted to find out the descriptive statistics of this. So what can I do? I can simply use the one method which is there in the Python, which is the inbuilt method of pandas. So I can simply use the data name. Okay, and I can simply use the describe method. Okay, I can simply use the describe method, and here in the describe methods you can be able to see the descriptive statistics. Understood? So in pandas it is very easy to find out the descriptive statistics of your data, right, by using a describe method, right? So first thing is that you can see the data. This is my data. Okay, now this is nothing but the descriptive statistics of your data. This is the count. Okay, this is, you can see that the number of the the values are there, total count of the data, right? The mean of your age, because age is the only numerical variable. That's why in the descriptive statistics we got the one columns description. Okay, only age. We got the count of the age, we got the mean of the age, which is nothing but the 23.75, right? We got the standard deviation of the age. Standard deviation is nothing but the variability or the variance in between the ages. Understood? Then what about the minimum value? Minimum value of the, or minimum age, is nothing but the 22. Okay, maximum age is nothing but the 26, right? You can see that the median age is nothing but the 23.5. Okay, then these are nothing but the quartiles. Okay, first quartile, second quartile, third quartile. Okay, so first quartile is nothing but the, okay, let's say you have the data from 1 to 100. Okay, so okay, then in the first quartile you will find out the data from 1 to 25. Okay, or the 25% of observations, which is nothing but the, which is inside the first quartile. So at the 25th percent observation is going to be your first quartile, so which is this 22.75. Okay, so if I took the example from 1 to 100, so my first quartile means the 25th percent of my observation is nothing but the 25. Then the 50% of the observation is nothing but the 50. 75th percent of observation is going to be 75, right? So here in the same way you can see that the 25th percent of the observation over here, then the 50% of the observation over here, and the 75th% of the observation over here. Okay, so let me repeat this by using a whiteboard so you can be able to understand this. Okay, give me a minute, so I can show you in the whiteboard. Okay, okay, now it is clear. Now guys, okay, let's take an example. Okay, let me take an example. Okay, let's say I have a data from 1 to, you know 1 to 100 values are there. Okay, so on the line, okay, you will find that, okay, there is 1, okay, and there is 100, right? So meanwhile, in between, okay, in the middle you will find that the 50 is there. Here you will find that the 25 is there. Here you will find that the 75 is there, isn't it? Okay, so this is my Q1. Q1 is nothing but the 25% observation. This is going to be the 50%. Okay, this is going to be the 75%. Okay, so here you will see that the 25%, 50%, and 75%. So these are the values of these. Okay, you will find that from here, from at the starting, okay, you will find that the, okay, first 25% of observation. Okay, if you sort the data, let's say my this 1 to 100 data is unsort data, you will find that the totally random data 75, 72, 62. Okay, like, okay, you will find that the 1 2 like this up to 30. So you will find that in that we have the total data is from 1 to 100. Okay, you sort this data, you just put it on the line, and you will find that the 25th percent of data is going to be 25, 50% of data is 50, 75% of data is 75. So in the same way, here you can see that this is the 25th percent of the data inside, okay, for this particular, for these four values. Okay, that's why 22.75 value is there, right? Okay, what about middle value? Middle most value is nothing but the 23.5. Okay, then what about the 75% observation? So 24.5 value is there. Maximum value is 26, minimum value is 22. Understood? Okay, this is nothing but the descriptive statistics. Okay, now, okay, you can check this, okay, for understanding your data. Understanding your data, like there is another thing is that, let me show you that one. Okay, if you are using the info method, is there any missing value in your data or not? How? So here you can see that the total entries in your data is nothing but the 4, right? There are 4 values are there in the count as well. You can see the 4 values. Okay, in the, okay, you just count it, you can see that the 4 names are there, 4 ages are there, right? So here you can see that the 4 entries are there, or simply the 4 rows are there in your data, right? So how many columns are there? Only 2 columns are there, name and age. So here in the name column, you will find that the 4 non-null values are there. Okay, if there is a missing value inside these, inside, let's say this is the missing value, let's assume that. So you will find that there will be 3 non-null value instead of 4, right? So if 4 non-null values are there, which means that there is no missing value in the data. Okay, we'll, okay, see this thing, okay, when we are dealing with the large data set, then you will understand, right? Now this is about the info method. You can use the info method to find out the null values in your data as well as the data types. Now you can see that in the data type you will find that the integer data type is there, as well as the object data type. Now what is object data type? Okay, as we know, name are nothing but the strings. Okay, these are nothing but the string data type, right? Names are nothing but the string data types. So these are nothing but the string value. But in the data frame, the data type is nothing but the object. So object and string are same. Okay, there is no, difference between the string and object. Okay, now let us go ahead, okay, and understand the further part. Okay, so now I just wanted to, let's say I just wanted to, arrange this, or this sort this data, in the ascending order. Okay, by using this age. Okay, because we know that, okay, this is nothing but the object. Okay, and this is the number, so number is more suitable to arrange, right? So we can arrange the data in the ascending order by using this particular age. Okay, how can add data? So if your table is very large, right? So that table must be stored in somewhere else, right? In the SQL format, in the, or in the Excel format, or in the CSV format, right? So you can read that data in the Python. Okay, you don't have to enter all the data or the table, okay, by using this. Okay, now let's go ahead and then sort the values. Okay, sort this particular data by using the age. Okay, now as we know, this is my data dot sort value. Now this is the one method we are using, sort values. Now by which column? Okay, by using which column I just wanted to sort this value by, okay, this column. Which one? Age column, right? And I'll be using the ascending equal to true, which means that, okay, sort this data in the ascending order, right? Now there is one more instead, interesting parameter is there. Okay, like the parameter name is nothing but the in place. Okay, the parameter name is nothing but the in place. Let me just add the in place parameter and I'll explain the the purpose behind this, why I just added this. Okay, let me run this, and here you can see now I just sorted the data by using this column H. See, 22, 23, 24, 26, right? If you go ahead and ascending equal to false, so you will see that you just arrange the data into the descending order, right? That's the difference. Now what about in place parameter? Okay, why I use the in place parameter? So here you can see I just use the data, sort values. Okay, these all the things with in place equal to false. Okay, so which means that I didn't change this particular my original data. Okay, I created the data, okay, just to show, okay, how to sort the values. Okay, if you wanted to do the changes in your original data like this, okay, then you can use the in place equal to true. Okay, let me show you. Okay, this is my original data. Which one? This is my original data, 24, 26, 23, and 22, right? Here you can see. Okay, this is my changed data, sorted data. Okay, let me show you the my data. Okay, now you can see the difference between this is my original data and this is my sorted data. Okay, this is just because of this in place parameter. If I use this parameter as the true, which means that I am making changes in my original data. Okay, let me go and run this. Here you can see. Okay, now I just made changes in my original data. Now I can simply see my data, and here you can see. Now the data is nothing but the 22, 23, 24, 26. I just sorted the data in the ascending order. So that's the importance of in place parameter in the you know the sort method. Okay, right? Okay, this is my data. Let me, okay, for that I'll have to again, okay, read the data. So that's why I'm reading the data. Okay, let me just run this. Okay, this is my original data, and now let's go over here and let me show you my original data. This is my original data, isn't this understood? Okay, this is my original data. Okay, I got the data from here. Okay, this is my original data, 24, 26. Okay, or otherwise simple words, again simply move this particular code over here so you can understand. Okay, this is my original data, guys. Okay, this is my original data, and this is my the sorted data that I'll just sort this data. Okay, let me go and sort this data into the ascending order by using the age column, right? And I'm using the in place equal to false, means do not make changes in my original data. I just wanted to see, okay, whether it is working or not. So for that reason I'll be using in place equal to false. So let's go and run this. Now here you can see I made changes in my original data. I sorted the data into the ascending order, but here you can see this is my original data. Okay, let me create the one new cell over here and I'll show you over here. Okay, here you can see. Now here you can see this is my original data, this is my changed data. Here also you can see this is the original, this is the original. These two are the original one, middle one is sorted data. Okay, right? Now if you wanted to make changes in your original data, this data or this data, so you can simply use in place equal to false, true, right? So if you use this, so you can see that now the data is going to be the sorted one, and you can be able to see now if you run this data, so you can find that now this data is also sorted one. Understood? So that's the power of in place. If you use the true, then you will be able to make the changes in your original data that you created over here. Okay, if you don't want to make changes in the original data, you can use in place equal to false. okay, and simply go with the further analysis without making changes in your original data, right? So for that reason, you will have to, create one more name for your data over here like this, okay, uh, data one, okay. So if you are not comfortable with making changes in your original data, you can simply do this thing, okay. You can create the new data. Like if you want to make the changes, if you are pre-processing your data, let's say you are cleaning your data, you just making changes, lot of changes in your data, like you just find out missing values, outlier, you replace those, you just drop few rows, okay. You just, clean your data in short, okay. Now why you want to do undo, okay, why you want to go with your original data? Original data is messy data. You just clean your data and now your data is ready for further analysis, right? So there is no, concept for doing undo, okay, for here. Now, okay, let me, okay, this is my data, right? So here what I can do is I can copy this cell, okay, I can paste it over here, okay, and let's say this is again my, let's say, df, my data frame, okay, and I'll make the duplicates, right? I'll simply make the duplicates, okay. So what I can do is I'll simply making the duplicates, okay. Let's run this, and this is my data, okay. Now I'm showing you the how you can pre-process your data. If there are duplicates, how you can, find out the duplicates, or in simple words, in directly how you can drop the duplicates, because there is no, reason to find out the duplicates and see the, duplicate value. If there are duplicate value, you can simply drop those duplicate values, right? So I can simply use a df dot drop duplicates, okay, and run this. So here you can see that I just drop the duplicates and now my data is this. You can, create as bigger data frame as you want. You can create the data frames with billions rows as well as a billion columns as well as a trillion columns, and whatever columns, whatever rows you want, you can create that much big data frame, right? Or you can easily scrap the data, mine the data from the internet as well. Yeah, that is nothing but a data mining or data scrapping in short, okay. So whatever big data you want, you can, get that particular big data in the Python. But there is a limit in Excel, right? There is a limit in Excel, like, okay, I'll show you that as well, okay. So okay, like for rows, so how many rows are there? The limitation of Excel is around 10 lakh, 10,000 around rows will be there, okay. If you exceed this limit, so you can't be able to, add more than that data inside the Excel, okay. And there are 60,000 columns are there inside the Excel sheet, right? One sheet. So but there is no limit over here in Python. Like if you wanted to look for primary key, okay, so primary key is the concept of SQL, okay, databases. It is a concept of that, not the concept of Python, okay. If there is a duplicate value, let's say this is the duplicate, yes, this row is duplicate row with this, okay. So Python has the capability to identify the duplicate rows, and it has the capability to drop those duplicate rows. There is no concept like primary key and, you know the foreign key, okay. That those concepts will be in MySQL, right? If there is a matching rows, then okay, like the rows are matching, okay, so then only Python will remove that, okay, because you will find that there are multiple column, let's say 10 columns are there, Okay, if the 10 columns values are matching for a few rows, so those columns are nothing but the duplicates column. Let's say if there is a column like the only 5 columns value are matching and remaining 5 columns value are not matching, so we can't say that column or that row is duplicate, right? If the all values in the row, okay, are matching with the another row, then we can say that those two rows are the, there is one duplicate row in that data set. Now let us go ahead. Okay, let me show you the few things, like what if, okay, let's say if you wanted to drop column. Okay, so if you wanted to drop the column, so is there any method to drop the column? Right, is there? Yes, is there any method to drop the column? Absolutely, there is a method. Okay, like there is a name and age in your data. Okay, this is my data. Okay, this is my data, right? Because here I didn't added the, the in place equal to true, that's why I got the, same data frame which is the original with having the duplicate values inside it. Okay, and now let us go and try to drop the one column. Now I'm just showing you, okay, like I'm not adding the in place parameter, right? Age. Okay, so simply use this and you can run this. Okay, sorry, there is a age is not found. Okay, because you will find, okay, yes, age is, okay, that's the one thing. Okay, I'll have to, this is a, the column is there. Now why it is showing that age is not found in axis? Okay, now what this mean? Okay, I'll have to add the parameter axis. Okay, you will find that, okay, axis is the one parameter is there, you will have to mention this. Okay, you will have to, dropping, okay, which, like column are you dropping or the row you are dropping, right? Absolutely, age is just a number. Drop it, right? So let us go with the columns. Okay, I just wanted to drop the column. Now here you can see, now I just drop the column which is nothing but the age, right? Like there is one more data frame which is nothing but the series, guys. Okay, series is nothing but the one single column of the data frame, right? So okay, if you wanted to create the series, so you can simply use the list. Okay, you can simply use a list. Let's say this is my data, I just wanted to create the series by using the pandas library. Okay, and I'll be creating the list 1 2 3 4 5. Okay, this is my, you know data. Here you can see, okay, this is a series, right? So with the help of this, you can simply use this and you will find that the data type of values, these values inside the series are nothing but the integers, right? So you can create the series as well, right? Then what about next? Like, let me show you, like, let's say if there are missing values present inside your data. Okay, let's say, let me use the import numpy for creating the missing value in my data as np. Okay, so now I can be able to create the missing values inside my data, right? Now here you can see that this is my data 1 2 3 4 5, right? Now I can simply use this data. I'll use the replace method, right? And I just wanted to, let's say I just wanted to replace 2. Okay, so if you wanted to replace 2 or 3 or any random value, you can simply put that random value over here and use the np, which is nothing but you are using the numpy library over here to, add the nan values. Nan values are nothing but the missing values. Okay, And here you can see that now I'll have to go with the in place, because I'll just, okay, I just wanted to add the missing value in my data, right? So here you can see that I just wanted to replace this 2 by missing value of nan. Okay, let me run this, and here you can see the data, okay, containing the missing value. Okay, if you wanted to add more missing values, so you can use the simply list, okay, like this. You can simply use the list like this, and you are free to replace the missing values, right? Let us go ahead with this. Okay, let's try to, you know, understand this thing. Okay, this is the thing you can do. Okay, now if you wanted to, as I say, if you wanted to add few more missing values, so here you can see, that's how you can add the few more missing values inside your data, right? Now there are a lot of things are there, like you can be able to, like you are free to, rename your column names. Like this is my column name, let's say, name is there, age is there. You can be able to, edit your column name. Okay, in the same way you can be able to edit your index numbers as well. You see index number 0 1 2 3 4 5. Okay, you can be able to edit these numbers as well. Okay, now for that you will have to use the one thing. Okay, let me show you, this is my data. Okay, now let's say this is my data. I just wanted to, rename this thing. Okay, now instead of name, I just wanted to explore, explain more about this column name. Okay, these are nothing but the name of the attendees. Okay, I just wanted to add this thing, name of the attendees, instead of name only, right? So here what I can do is I can simply use the data, okay, dot rename. Okay, data dot rename, and here you can see that I'll be using the columns, right? And inside the columns you will find that I'll be using the which column name I have to change the name, right? And which is the new name. Okay, which one is the new name? So here is the new name of attendees, right? So this is how you can do. Okay, you can add the in place equal to true to see, yes, we are making changes in the data, and you can see the data, right? You can see name of the attendees over here, right? Data type is nothing but the data frame. Like in the starting we just created the data frame, so the type of this whole table, okay, type of this whole table is the data frame. This table is nothing but the data frame, right? In the info you will find out, okay, where, see, core is nothing but the data frame, right? See, okay. And if you wanted to see the, types of your elements values inside your data, so you can see the integer and objects. Okay, if you want, okay, you just wanted to change the this number, index number. Okay, let me show you how you can able to change the index number. Now let me go ahead again over here. Okay, now I just made the changes in the columns. Okay, now I just wanted to go ahead with the indexes, right? Okay, so let's say I just wanted to change the index number, let's say 0. Okay, and I just wanted to add this 0. Okay, so I can simply use this, and here you can see in the data you will find that the 0 index number is there. If you wanted to change the more index number, you can free to change it. Okay, like this. See, we just made the changes in the index number. We just rename those index number. Understood? Okay, so now here you can see that now there is 2. You can use this as the you know 2. There is 0 value is there, right? So you can use this as the 1 2 3, right? And you can see this thing, see 1 2 3. So in the same way you can rename the fourth one as well. So for that, okay, let me create a one dummy data, okay, for group buying our data. So let's say, okay, df pd dot data frame. Okay, with the help of this I can be able to create a data frame. Okay, let's say key one is there. Okay, this is my first column name. Okay, I am adding few let's say a values to it. Okay, okay, for group buying. Why am I adding duplicates? Because in the group by you will find that we are just grouping by the data. Okay, so that is why we are doing this thing. Okay, let's go and add the key to, okay, with, let's say, again, okay, now I'll have to add few numerical variables, okay, which means we can be able to apply the group by method, okay, by using those numerical columns. Okay, like we are applying some aggregate function like mean, right? So for that, okay, let's say uh, v1 is the column name. Okay, and let me add a any random value. Okay, so instead of taking this random value, what I can use is I can use the numpy library, okay, for selecting the random values. Yeah, so it's totally in a random way we'll be getting the values. Okay, so okay, random numbers. Okay, basically we are using the numpy library as np dot random method is there, okay, which can generate the random numbers. So these are nothing but the random numbers we are generating. And how many random numbers we want? Only 5, because here you can see that the 5 values are there. You will see that the 5 values are there, right? So this is the first thing. Okay, I'll go with the another v2, okay, with another random numbers, right? I'll complete the data frame. Okay, no issue with this. Here you can see I just completed it. Okay, so let us go and I'll show you the data frame, how the data frame looks like. Okay, this is my data frame. Now here you can see that the two columns which are the objective, two columns object, two columns are the numerical one. If you want to see this, so you can simply use the info, right? With this here you can see that the total 5 entries are there, 5 rows are there in my column, total 4 columns are there, okay, there with their index number 0 1 2 3 4, right? And how many values are there which are non-null? Okay, so in my 4 column you will find that the 5 non-null values in each column. So you will find that the total entries are 5 non-null values, which means there is no none value, right? And here you can see that the data type for each column, like for these first two column are object and second two columns are float. Now we know that float is nothing but the decimal point. You will find that the numerical values containing the data, decimal points. This is nothing but my info, right? Now let us go ahead and apply the group by function on it. right? So let's say if I just wanted to apply a group by function, or the I just wanted to see the let's say the mean of these two column, okay, by using the, let's say, key one. Okay, there is a key one. So I just wanna check the the key one. Okay, the mean for each value. Okay, let's say there are two unique values are there. I just wanted to see the mean for this. Okay, how can I get this? I'll use a group. Okay, I'll use a data frame. Okay, you know that. And here I will be using the, let's say, v1. Here you can see v1. Okay, and I'm applying group by on it. Okay, I'm applying group by on it. And which column we want to group by? Let's say the first column, key one column. Understood? Okay, so here you can see key one column is there, and I am applying is group by. Okay, group by dot mean, just the get the mean values. Okay, if you see this thing, so you can firstly see this thing. Okay, sorry, group by is not defined, grouped is defined, right? So you can see that the group by object is there. Okay, series group by. So what I can do is I can simply find out the mean for the data. So here you can see this is my key one. Okay, I just group the key one. You can see that the key one, and inside the key one there are two values, unique values are there. First unique value is A, second unique value is B. Okay, and here you can see that. Okay, these are nothing but the mean values for v1 column. For which column? For v1 column. You here you will find that the how many A values are there. Okay, this thing, the second this thing, then this one, right? So I added this three value. Okay, I just find out the mean of these three value. So the mean of these three value is this, and the mean of these two values 0.78 minus 1.22, the mean of this is going to be minus 0.22, right? So this is how you can apply the group by method on it. Okay, again guys, this is very much important. Group by method is very much important. Okay, so let's discuss that. Lock method and iLock method, what is that? Okay, so here you can see that the lock is nothing but the the parameter name, the column name. Here you can see that the how many column name are there? Okay, four column. Let me show you here. Okay, how many column names are there? Four columns, and their index value here you can see 0, 1, 2, 3. Now what I can do is, now if I just wanted to select the key one parameter and the v1 parameter. Okay, so with the help of lock method, with the help of lock method giving me the permission to select this parameter, these columns. So I'm selecting this key one. Okay, I'm also selecting this v1. Okay, and let me run this, and here you can see. Okay, this is nothing but the lock method. Okay, now you can choose any value over here. If you want to select the one column only, you can go with the one column, right? It's totally up to you. Okay, and what about iLock method? iLock nothing but the index location, right? iLock is nothing but the index location, right? So here you can see that df.ilock. Now instead of taking the names of the column, I will be taking the index of the column. Now this is a zero index column, this is a first index column, this is a second index column, this is a third index column, right? So if I wanted to extract the second index first index columns, so I'll simply use this. Okay, I'll simply use this first index column. Let me run this. Here you can see. Okay, sorry, I got the row. I'll have to add this thing. Okay, all the rows, and here you can go. Okay, now basically this is my first index column, you see. Okay, I got the error value first, because if I use these, so here you can see that the iloc, which means index location, if I use only this, which means it will consider the row. Understood? It will consider the row. And like I got the values a to 0.79, 0.097 for this particular row. Got it? Okay, so if you wanted to go ahead with the column, so you can simply use the all rows comma the first column. Okay, all rows comma and first column, right? Now, okay, this is the thing. Now if you wanted to select only, let's say, okay, I just wanted to select this many, okay, this a, okay, this many data, okay, this b data and 1 2 data, these two columns data only, this much square I want from my data. Okay, what I can do is I can simply go ahead with df dot either log or iloc. Let's go ahead with iloc. Okay, and what I'll do is I'll go with the index number of the rows like 2 and 3. Okay, so I'll use the 2 comma 3 comma 4. Okay, this is nothing but the 2 3 4. 4 is excluded here. Remember guys, 4 is excluded here. Understood? Now what I can do is, this is a index 1 0 column, this is a index 1 column, this is a index 2 column. As we know, index 2 is excluded, right? So here what I'll do is I can simply go ahead with this one. Okay, let me run this. Here you can see bb values and 1 2 values. Okay, this just square this much. Understood? Okay, this is how you can select any small subset of your data frame, right? You can use anything. Okay, you can use anything, and you can go ahead with either iloc method or the lock method, right? Now let us talk about the next thing. Okay, let's say, okay, let's say here you can see that, okay, let's say in the, let's say in the v2, okay, few values are negative, few values are positive. If you wanted to select only positive values, right, if you wanted to select a only positive value based on the v2 column, if you want to select only positive rows, okay, values, let's say this is a positive row, I can say, because the value for v2 is positive over here in this particular row. I just want to take this particular row. Here you can see that this is a positive value of the v2 column, so I just want to take this particular row. So how I can do this? So there is one which is very interesting method is there. Just use the data frame, your name of the data frame, your name of your data. Okay, and here just add the your column name. Okay, and add one condition. Okay, your column names v2's value should be greater than 0. Okay, if your value is greater than 0, so it will be in the, you know, in the your data or not in the data. So these are nothing but the boolean concept. Okay, you just added one condition over here, and just by adding this particular condition, you know, it's very easy to take the, you know, positive columns by using the v2 column, you know, positive rows by using a v2 column. Okay, there are a lot of functions in the, you know, python. Okay, all we need to is just explore those functions, right? So if you want to explore those function, you can simply go over here, you can simply refer this reference of python, and you will understand all this thing, because you know, pandas is very much big, right? So it's not possible to explain each and everything over here inside this particular session. Okay, if you wanted to explore again much deeper into that, so you can simply go ahead and feel free to explore more. If you have any question, you can simply join with me on LinkedIn. Okay, for any upcoming question, welcome. For creating the numpy arrays, arrays are nothing but the matrix in 1 dimension, 2 dimension, 3 dimension and more dimension, right? Then by using numpy you can create the missing value. As I used np.nan, so that is nothing but the, you know, you will see that, okay, where it is nan. Okay, here you can see np.random. I used numpy library to generate the random numbers in, okay, 5 random numbers in between, anything, you will find that the any random number you will see. Okay, you can use the numpy library for, the nan values, adding the nan values. Nan values are nothing but the missing value. You just added the missing value over here, right? So you can also use numpy library for doing some statistical analysis. Will be okay, we'll see those statistical analysis in upcoming part of the session, right? Series is just the number, okay, sorry, is just the one column, I would say. Okay, so see, this is my data. Okay, let's say this is my data. Okay, and if I selected the one column, only this column, so this is nothing but the series. So that is the difference only, not any other, right? You can create the series by using the list as well. You can create the series by using the list as well. Here we just created it. Here, see, here we just created the series by using the list. Okay, this is just the one column, I would say. Okay, nothing else. Now this is how you can do sub. You can just select the sub part of your data by using this multiple things: lock method, iLock method, this particular condition. You can put the condition as well. Now one more thing is that, mind that, okay, you got the data, okay, and you don't want to make the changes in your original data. So at that time, what to do? Like, let's say this is my data, df is my data. So what I can do is I can simply create the data too, okay, by using the data one dot copy. Copy is nothing but the, I got the new data frame, but this one is nothing but the copied data frame. So instead of using your original data frame, you can simply use this data frame, which is your copied data frame. Understood? Yeah, so that's the thing, right? Now guys, okay, uh, after this, let's go ahead, okay, and try to explore the data visualization part. Okay, try to create some plots. So again, I created this data frame. Okay, I took the data frame, which is a very small data set, subset, I would say, not a very big data set. So for that, okay, first, what I what I need to do, here you can see that, okay, this is my folder. Okay, this is my day2 folder, and here you can see that the data set folder, right? So in the data set, you will find that the multiple CSV file is comma separated version file. Yeah, here you can see that I'll be using this national parks data for creating histogram, right? So guys, try to download that particular data. Okay, you can simply download all the data, so we can simply go ahead with all the data. Okay, for creating histogram, we need few libraries to import. Okay, and what are those library? First library is nothing but pandas library. Why we are using pandas library? Because pandas library is very important library to read the data set, right? So let's say we are importing the pandas library, and what we are doing over here, yes, we will be importing Matplotlib library. Okay, first thing I'll be showing you how you can read your CSV file in Python. Okay, so that's what I'm showing you right now. Yeah, so let's say this is my data. Let's say NP data is there, which is nothing but the national parks data is there. So what I am doing is I'll be using the pd dot read underscore CSV, and in the bracket I'll have to add the you know data name. But here you can see that this is my day2 folder. This is my this is my Jupyter notebook, okay, file saved over here. And Here you will find one folder data set, and in that folder we have one CSV file, and that I just want to read over here. Okay, so what I can do is I can simply go over here. Okay, I'll simply use the data sets slash backslash the name of the this file. Okay, national parks, national underscore parks. Okay, dot csv, the format for that particular data set. Now here you can see, let me go and run. Okay, now we just able to read the data in the Python. Now how to see the data? Okay, so you can simply go ahead with this np.data. You can simply use this. Now you can see this is my data. Now data is around 56 rows are there. Okay, now what I can do is I can simply, I don't want to see whole data. Okay, this is my header method. It will show us the top 5 entries of your data set. If you want to go with the tell method, okay, you can simply go with the tell method. You will get the last 5 entries of your data. See the last 5 entries with index number. Okay, if you want to see the sample, the random data, okay, random rows, so you will see that the sample, this is totally. If you want to see the sample of 10 rows, so you will see that. Okay, sample of 10 rows, which is totally randomly selected. See, index number is random, right? So this is how you can go ahead with. So here I just selected, I just go ahead with the format name. So there is no need, sometimes, okay, there is a need to select the you know this thing. Okay, Python gives the one method, read underscore csv. With the help of this you can easily read the csv file without any issue, right? Because here our aim is to create the histogram. Our main aim is to create the histogram, right? So that's what we are doing over here, right? So let's go and create the histogram now. Okay, for creating histogram we need to import matplotlib library. Okay, matplotlib dot pyplot as plt. We are importing matplotlib.pyplot as plt. Okay, so you can also do the same thing. Okay, so let me first import this library. Okay, so use this matplotlib library dot pyplot in terms of plt. Okay, so use the plt dot, for creating histogram simply use the hist code. Okay, for creating histogram. Now here you can see that, okay, how many columns are there? Total 4 columns are there, right? So now I just wanna create a histogram, let's say by using this particular column. Okay, I just wanted to use the histogram by using this particular column. So what I can do is I can simply use this. Okay, let's say np my data. Okay, and in the square bracket you will find that I just want to copy this particular name. Okay, column name, and here one more thing, because histogram is this. Okay, because histogram is this, so for that histogram I just want to select the how many bins I want, right? How many bins I want. So let us go ahead. So after this, after adding bins equal to 10, okay, you can go with any random value of bins. Okay, but try to set the bins value which is a small one, not the more than the I guess 15. Okay, because if you are creating the let's say more than 15 bins, so you will find that the very short bars you will see. Okay, so that will make confusion. Okay, so after this, okay, let's go ahead with this and use the plt dot show the plot, and let's go and run this. And here you go, we got the plot with this. Okay, we got the plot with this. Okay, now if I wanted to change the let's say if I wanted to change the color, these are just the basic colors. Okay, this is the default color. Okay, I just wanted to change the color of this. So what I can do is I'll use the face color. Okay, I'll use the face color parameter to change the color of the bins. Okay, so which color we want? Let's go ahead with the red one. Okay, let's go ahead with the red one, any random color. Okay, now here you can see the on the edges here we don't see any color. So let's go and color the edges as well. So edge color is there. Okay, this is again the next parameter you can see. Okay, and what different color you want? Now let me set this edge color as a you know the black one. Okay, not black one, let me select the blue. Okay, because the color combination you can see. Okay, and let me rerun this again. Now here you can see. So this is how you can go ahead with. Okay, this is how you can go ahead with. Okay, this is a simple bar plot histogram. Okay, now uh, here you can see the bar the histogram is there, like the this thing. You will find that the this particular histograms you will find that this is a very high you know bar is there. Okay, in the histogram like this. So you can, I'll be explaining the bins to you. Okay, so let's say again we have the data from 1 to 100. Okay, for for our understanding, that's why we took the data. So if I wanted to create the bin, okay, like here you can see. Okay, these are nothing but the bars. Okay, these are nothing but the bars. And how we can create it the bars? By using the bins. Now here you can see that I just created the one bean from 1 to 10, second bean from 11 to 20. Okay, third bean from 21 to 30. Like this we just created the 10 beans from last bean is going to be 91 to 100, right? So these are my 10 beans, right? So these are my 10 beans. Understood? Okay, I created this bin. Now in my 1 to 10, how many values are there in the 1 to 10 range? Let's say 7 values are there. In 11 to 20, how many values are there? Let's say 12 values are there. In this particular bin, how many values are there? Let's say 6 values are there. Like this you will find that. Okay, all bin values. Okay, in the 91 to 100 we have the only 4 values, you see. So you will find that. Okay, that's what we are. Okay, we just created this kind of data. This is the frequency distribution. Okay, and here you can see we just created the histogram by using that. If I wanted to again I just wanted to make the cumulative sum for this. Okay, I just want the histogram in the cumulative manner. So what I can do, I can simply add the one more parameter, which is nothing but the cumulative, right? Cumulative equal to true. So here you can see, just by adding the cumulative equal to true, we just arrange our bars. Okay, we just arrange the histogram in the ascending order. Okay, understood? So that is a simple thing. Okay, now let's say uh, let's say uh, if I wanted to draw the multiple histogram, let's say this is my first histogram. Okay, and I just wanted to create another histogram. Let me copy this. Okay, this is my another histogram, right? But with another column. I just want to take another column name. Let's say take this column. Okay, and you will see this thing. Okay, instead of red, let me go ahead with the, let's say, the next one, which is anything. we can go ahead with orange, and let's see how the plot looks like. Okay, and here you can go. So here you can see that, okay, the plot is there. Okay, so here we are not able to see this thing. Okay, we are not able to see this thing, so that's why we will have to arrange the colors. Okay, if you see, take the color combination, so you will find that this thing. Okay, so plus, okay, you will have to, add some, some, blur thing over here. So for that, you can use one thing. Okay, you can do this thing like, let's say if I just wanted to add over here is, okay, alpha value. Okay, so with the help of alpha, we'll be able to, uh, we'll be able to see the transfer colors. Okay, transparent colors, right? So here you can see. Now you can see that the alpha value is 0.3, and with this value, okay, we'll be able to see the transparent colors now. So we can be able to see the intersection of the data. Okay, you can simply cut this particular cumulative term from here. Okay, and you can, and you will see. Okay, now you can see. Yes, now is it, it is original in shape. Okay, so that's how you can go ahead and explore more about this. Okay, okay, in machine learning it is very important to see the intersection of the data. Let's say if you are building a model for the prediction purpose, so at that time it's very important to see the, the intersection of the data. Okay, if both the data are, are far away from each other, then you can see that yes, they are, contributing with higher weightage for creating the machine learning model. Okay, we'll be talking about that in the upcoming part of the sessions. Okay, so this is just the, just the histogram. Likewise, we have the other parts, other charts as well, like the pie chart. Okay, let's create the pie chart. Okay, then we'll go ahead the multiple charts again. So this is the intersection of the data, guys. Here you can see this is the intersection. You can see now this transparent plot. Okay, we'll be able to see this transparent data. Okay, so here you can see the this thing. Okay, now if you wanted to change the value of alpha, you can change the value and see the results as well. So you are free to change the value of alpha and you can see the result. This is for the exploration purpose. Okay, you can do that by yourself. Okay, now let me copy this. Okay, to again. Now here, what we are doing, we are just creating the pie chart. Okay. So here you can see the, this, let's change the data set. Oh, sorry. Mm, No need to see the data because here you can see by mistake, I just double click to the data set. So now let us go and see the types movie. Okay, types of the movies. Okay, so types of the movies. So let's go and run this. And now, mm, okay, no issue. Let's say instead of taking data, I'll be taking this as the only data, not the NP data. Okay, so data dot head, you will see that the this thing. Okay, now why I just change the different data, why I use the different data, because here you can see that in the data set you will find that the percentage. Okay, now I just created this dummy data to show you, okay, how we can create the pie chart, right? How we can create the pie chart over here. Okay, so we can simply use the plt.py. Okay, we can use, let's say, the movie percentage. Okay, our data It's simply we can go here, we can copy this, okay, we can paste it over here, okay. Then the secondly, we'll have to use the labels, okay, labels for this. So you will see the labels as well, okay, in the pie chart. Labels are nothing but the sector, right? Now you can see the plot over here, okay. You can see the plot over here, right? Okay, this is just the starting. Now if you search for the pie chart, or the if you search for the plt matplotlib library from here in the references, you will find that for this particular pie chart there are lot of parameters, right? There are lot of parameters, which means you can add the values inside this, okay, as well as you can create the different kind of pie chart as well, okay. So you can do this multiple things, okay, like you can add the multiple let me show you the one so you can understand, okay. Let's say I just wanted to add the values for this. I just wanted to add the values, okay, for this. So for this I can use auto pack, okay, sorry, auto packed is there, and with this you can be able to add the values, okay. Now if I just wanted to add the values, let's say in the in the two decimals, okay, up to two decimal, let's say. So what I can do is I can simply use this percentage dot 2f. 2f means two floating point numbers only. Now in the second I just wanted to see this exploded pie chart, okay, just explode this pie chart, okay, and we can be able to see this. Oh, I got the error. Okay, and what was that? Okay, explode is not defined, I guess, right? So for this, I'll have to, add the explode as well, right? I'll have to, the number, so we can be able to see that particular thing, right? So like exploded means the breaks, okay, which means that you will see this thing, okay, where you will see the pie chart separately. Each part is separate, right? Let me show you, okay. uh, Let me, I just wanted to show you the two parts separately, okay, like this, okay. So here you can see, so here, okay, this first part I just separated and last part I just separated. So here you can see, right, with the numbers. So is it cool or not, right? It is very easy to show you, because okay, if sometimes, okay, if you wanted to, let's say, okay, let me make it 0, then you will understand. Okay, let me run this, okay. Sometimes you will see that, okay, you wanted to just show this particular domain, okay, show this particular genre, I guess. So at that time you will have to mention this, you will have to separate it from the pie chart, so you can apply this thing over here, right? And you can use this for anyone. You can use this for skypie, okay. Let me and go with this, okay. Like the comedy, you can, if you wanted to go with the skypie, you can use this, okay. See, now this is the drama, I guess. Okay, 0.3. Okay, now here you can see this is the skypie, okay. So this is how you can go and you can explode the pie chart, okay. That's the thing. This is just the simple pie chart, I would say, okay. There are a lot of things you can do with the pie, okay. Now let us talk about the box plot. Box plot is one of the most important plots, okay. So let us go ahead and take yet another data, which is, let's say, take the exams data, okay. Now, okay, again use the, let's say, df equal to pd dot read underscore csv in the bracket. You will have to mention the, data sets slash exams dot csv, right? And let's run this and see the, now I got the, here I just missed the e letter again. What is the problem? Okay, see, no such directed data set exams. Again, this is the problem. There is a spelling mistake. Okay, let me go and run. Okay, and here you can see your data, right? This is my data. Okay, this is my data. Around 100 rows are there, 8 columns are there. I don't want to see this much big data. I just wanted to see the first 5 rows only, the sample data. Okay, so this is the thing, right? Now I just wanted to, create the box plot for this. I just wanted to create the box plot for this. So what I can do, I can simply use the plt dot box plot. Okay, and here you can see that for, for few columns. Okay, let me show you. So see, someone getting, error as a name error, name plt is not defined. So plt, you will have to define the plt first. And how you can define the plt? By using this particular line of code: import matplotlib dot pyplot as plt. So use this particular line. Okay, run this particular line, then that particular error will gone. Okay, okay, now let's go ahead with this particular thing. Okay, this is a box plot. You will see that, okay, the minimum value 25th quartile, this q1, q2, q3, and maximum value, you can see this over here. Okay, this is just a box plot, simple box plot of one column, which is nothing but the math score. Okay, this is the minimum value, this is the maximum value, this is the first quartile line, this is the middle value or the median, or the second quartile line, this is the third quartile. You can see over here, this is the minimum value 36. See, minimum value 36 less than 40. Then at q1 25th quartile, 56 value. Here you can see the less than 60, 56 value. Like this, you can see the, 76 and the 95. So 76 is over here, and the 95 is over here. Right? Understood about the box plot? Now let's go ahead and see the last plot. I know there are a lot of plots, but we will be exploring only few plots. Okay, not the all the plots. Okay, because after the practical we have some, theoretical knowledge as well to gain of statistics. Okay, what about scatter plot? So we'll be, okay, we'll be taking countries, data set in the scatter plot, right? So let's go and use the, df equal to pd dot read underscore csv in the bracket, use a data sets, and in the inside we have the countries. Okay, countries dot csv, right? And let us go and run this. And here we go, this is my data. Create a scatter plot. So scatter plot is very much simple. How you can do this? Plt dot scatter, right? You can use this plt dot scatter. You can use the, the name, let's say this life expectancy and population. Okay, so let me go ahead with the, because here you can see that. Okay, let me use this life expectancy first. So what I can do is I'll use a df. Okay, either I can use life, directly life expectancy, because you don't see the any space in the column name, right? This is the first, this is the second column, population. Okay, and here you can paste it, right? And let's run this, and here you can see the, you know life expectancy and population column is there. Okay, if you wanted to see the life expectancy and gdp per capita, so you can use this thing as well. Okay, So here you can see the life expectancy and GDP per capita, right? So this is how you can go ahead with. This is just the example, guys. Okay, this is just the example, right? Okay, if you take the year here, okay, if let's say if I am taking the year over here, okay, df dot year comma, and let's run this. So here you can see the you know some kind of increment, but in the because year is in the discrete manner, you will find that the 150, 160, 170, 190, that's why you will see this kind of lines. Okay, so that's the things. Okay, so you can create the box plot like this. Okay, so now after this, let us go. Okay, now we just done with the, let us go and part, because as I said you earlier, okay, this is about, okay, in the agenda you will find that always 80% practical is there and only 20% theoretical knowledge is there. Okay, so let us go and understand from here basic statistical concepts and below concepts. Okay, so when you are collecting data, okay, so you are collecting data, so for that this level of measurement is very much important, right? So here you can see, let me, okay, when you are collecting data, so this level of measurement is become very much important. Okay, why? Because you will see that, okay, let's say you are collecting a data of the blood group. Okay, A positive, B positive, AB positive, O positive, like that you are collecting data. So that is just the that is some kind of blood is there, okay, with some some speciality or some some differences is there. So that's why the professionals, okay, just label them, okay, label them as a positive, B positive. So this is just the label data, right? With no ordering, there is no order, right? Like like someone name is Mahesh, someone name is Suresh, like that. So we can say that this is just the label. Okay, this is just the label, so that is nothing but the nominal scale. Okay, that is nothing but the nominal scale. Now what about ordinal scale? Okay, do you know about Olympics? In the Olympics, okay, how many medals are there? Gold medal is there, right? Silver medal is there, bronze medal is there, right? So total 3 medals is there. So gold is the first and the best medal, right? Then second, on the second position you will find that the silver medal, on the third you will find that the bronze medal. So that is nothing but the ordinal scale data. Okay, you just categorize the data into the rank wise. Okay, like the rank wise you just categorize the data like gold medal, silver medal and bronze medal. Okay, what about next? So we have the next scale, which is nothing but the interval scale. Okay, so if we talking about the example of interval scale, let's say, okay, let's say uh, you are a college student, okay, and uh, you know you are just your teacher are taking the exam, and your teacher set a passing criteria of 40% marks. Okay, if someone who got the more than 40% marks, so he qualifies the exam or she qualifies the exam, right? So that's how, okay, that is the first thing. Now let's say second teacher taking the second example. Okay, now that teacher said the passing criteria is 30%. Okay, now you can see that the passing criteria is changing 40%, 30%, 35%, like this. So that is nothing but the interval scale. Here you don't see any true 0 point. Okay, now the true 0 point means, okay, let's say, okay, you know the height. Okay, zero height means no height. Okay, if there is a someone with 5 feet, so we can say that the 5 feet height is there. Okay, so height is starting with the there is a true 0 point is there for the height, for the age. Okay, starting point for the age is 0 year, newborn baby, right? So but in the interval scale you will find that the criteria is changing. There is no fixed true 0 point is there, like a passing criteria is 40%, passing criteria is 30%, 35%. So that is no true 0 point is there. So you can categorize that data, you can rank that data and infer equal interviews, you know intervals between neighboring data points, but without true zero. So that is nothing but the interval scale. Now what about next? Ratio scales. So lot of data which we are collecting, that is coming from the ratio scale, because there is a true 0 point, like our age. Okay, zero age means newborn baby, right? The height is zero means zero height. Okay, so there is a true 0 point. We can't change the true 0 point. We can't say that the 10 year is is the the age of the newborn baby. Newborn baby's age is just we can say the 0 year, right? We can't say the 10 years 10 years old boy is a newborn, right? So that is the thing. So these are nothing but the level of measurements, and by using these four scales or the four level of measurement, you can collect your data. That is the first thing. Okay, what about second? Okay, random variables. Okay, like as we know in Python, we created the variables. Okay, like the x variable, y variable, and a variables in Python are nothing but the containers. Okay, that those are just storing the data, right? So here in statistics, random variable is also the same. Okay, but here you will find that in the range. Okay, let's say if there is a random variable x. Okay, but that variable should have the range. Yes, definitely we'll share the ppt in the pdf format. In the random variable you will find that the two types of variable, first one is a discrete variable, second one is a continuous variable. So if we're talking about the discrete variable, so those variable we can count. Okay, we can count. So that is nothing but the discrete variable, like the number of the patients coming in the. Okay, number of patients we can be able to count, right? Isn't it? But we can't count the time. Okay, we can't count the time because time is continuous manner. Okay, continuously it is going on. Okay, so that's why we can't count the time. Okay, as well as we can say that age is uncountable, because okay, like the age is also depends on the time. As times is passing, age is increasing. Okay, as we know, we can't count the time. Okay, why I am saying this? Because you will find that there is 1 hour, we can count this. Minute, we can count this. Second, we can count this. Then millisecond, yes, also we can count the millisecond. Then nanosecond. Then we can't count the nanosecond. Then less than that. Okay. So likewise, you will find that you know we can't count the time. So in the same manner we can't count the age. Okay, but we can note that. Okay, like the now. Okay, let's say my age is let's say 30. Okay, so you can say that I just told you the age in terms of years. Okay, I can tell you the age in terms of years and months, years and months and days. Okay, years and months and days and hours, minutes as well, second as well. Okay, but you will find that this is a continuous process, so we can't count. So which is nothing but forever to count, that is nothing but the continuous variable. This is the few basic statistical concept. Okay, we will have to understand. First one is how we can collect the data. So with this four scale we can be able to connect the data. all kind of data we can collect by using these four scales. Okay, and what is random variable? So first discrete random variable is we can count that random variable, right? Any other example, height, weight. Okay, weight in kilogram you count, okay, in gram you count, then after that milligram you count, nanogram you can't count. Okay, right? So like one more example is nothing but the rational number, right? 1 point, like after decimal, if you add the 1 trillion numbers, okay, 1 trillion numbers, so it's not possible to count. Okay, let me show you another example for this. Okay, this is very interesting. Okay, let's say if I tell you, okay, can you tell me how many numbers are there in between 0 and 1? Infinity? We can't count. So this is nothing but the continuous process. So if we, let's say if we starting from the count 0 point, we don't know the next number. We can't say after 0, we can't say this is the one number. Let's say if I say 0 point is my one number. Okay, and what about 0.01? Okay, if I say this is my first number after 0, what about 0.001? Right? So this is the continuous process, we can't count. Okay, so this, okay, these are the, example of the, you know the continuous variable. Understood? Now let us move ahead and understand the probability and probability distributions. Okay, as we know guys, probability is also known as the chances or the possibilities. Okay, let's say, okay, if we talk about the probability, like let's say if there are, 10 person are there, right? If there are 10 person, okay, let's say total 10 person are there. Okay, let's say value of n is 10. Okay, and I have only 7 chocolates. Okay, I have only 7 chocolates. Okay, so, okay, so what is the probability of getting, the a chocolate to each person? Okay, it's nothing but the 7.10. Okay, number of favorable events divided by total number of event. So here, okay, favorable, okay, number of favorable events are just 7 and total number of event are nothing but the 10. Means that total 10 person are there but only 7 chocolates are there. So the probability of getting a chocolate to each and every person is nothing but is 0.7. So that is nothing but the probability. Okay, means the chances, right? So we can say this probability is also the branch of statistics that deals with the occurrence of a random event. Like I told you the example of the probability. Yeah. Okay. The value of probability will always lies between 0 and 1. Okay. Value of probability is always lies between 0 and 1. Okay, so now, okay, what about the values are the probability is lies between 0 and 1. You always see that. Okay, if the probability is the exceeding this range, if the probability values is more than 1 or less than 0, so which means that this is not the probability. Okay, you made some calculation mistakes, that's why you got the value which is less than 0 or greater than 1. Okay, so that is the thing. The formula of the probability, as I told you, the formula of probability is going to be the number of favorable events or outcomes of the event divided by total number of outcomes, right? So that is nothing but the formula of probability. That, okay, this the same formula we used, 7 by 10, right? Then this is the simple example of probability. Yeah, what about next? There are a lot of probability distribution. Okay, why we need distribution guys? Because distribution, with the help of distribution, you will be able to understand your data distribution. If you know the distribution of data, so you many times you don't have to even find out the mean of your data. Okay, if you know the distribution, you can easily calculate the mean of your data instead of just finding the sum of all. If you have the millions of rows in your one column, so at that time finding the mean, it's also become a very critical process, right? So if you know the probability distribution, which means, and it's very easy to find out the mean, okay, without calculating anything, right? So there are two types of probability distribution. First is nothing but the discrete probability distribution. Second one is the continuous probability distribution. If we're talking about discrete probability distribution, so you will find that the binary distribution. Okay, why we need this thing, guys? Okay, let's say we are building a machine learning model for the classification, classifying the whether whether a customer is doing a fraudulent activity or a customer is genuine. So here you can see that we have to build the machine learning model for predicting a customer is fraudulent or genuine, right? So there are two classes, fraudulent class and genuine class, right? So by using binary distribution say there are only two classes, okay, with the probability 0.5 and 0.5. But if there are lot of values are there, a lot of rows are there, so it becomes binomial distribution, which is a again discrete probability distribution. You can note it down somewhere else, okay, and after the session you can search for that. Okay, first is binary distribution, then is binomial distribution. Okay, and we'll be using binomial distribution in the classification model of machine learning. We have the third Poisson distribution. Okay, the very popular example for this is nothing but the number of accidents that is happening in particular area. Okay, we don't know the how many accidents will happen in that particular area, right? Just by the previous data, okay, you can use the Poisson distribution and you can find out the probability of accidents that is happening in that particular region, right? So you can do this by using a, so let's say if there is a 90% of chance of happening accident in that particular area, so you are just you know you will not go there, right? So that is the thing, right? So that's what you can do with the help of distribution. Then we have the geometric distribution, then we have the hypergeometric distribution. Likewise, we have so many distribution which are discrete probability distribution. As we know, guys, discrete is nothing but the number which is countable, right? So that is the difference between the discrete probability distribution and continuous probability distribution. Now what is continuous probability distribution? We can find out the probability distribution of continuous random variable. Those are continuous probability distribution. Okay, like our normal distribution is continuous probability distribution. We'll be talking about that, guys, in the upcoming part of the session when we need to apply data transformation in the data pre-processing step of any machine learning projects. So at that time we need the normal distribution. Then we have the t distribution, chi-square distribution to check the variability, okay, to check the variance in the data set in the columns. Okay, at that time we can use this. Okay, likewise we have the exponential distribution to check the mortality rate. In the actuarial science we will be using that particular distribution, right? So these are the few distributions are there. Okay, now let's go ahead with the further part, which is nothing but the sampling technique. Okay, which is nothing but the sampling technique, right? Now here you can see that in the sampling technique, what are the different sampling techniques are there? Simple random sampling. Okay, we are taking the samples totally okay, we are selecting the samples in a random manner. Let's say we have the 1 to 10, 1 to 100 data points, and we have to select the 10 data points from that. Okay, so we can select those 10 data points in a random manner. We can select any 10 data points. Okay, that is nothing but a simple random sampling. What about next? Stratified random sampling. You can create the strata. Okay, strata is nothing but the groups in your data. Okay, and those groups are nothing but the uniform groups. Okay, then next we have the systematic sampling. Okay, if we're talking about the systematic sampling, so let's say, okay, like in a school you will find that the row of the benches, right? Let's say there are 4 rows of the benches in one classroom. Okay, and you are applying systematic sampling, which means that, okay, let's say you are just taking a second row of benches, the students from the second rows of the benches. That is nothing but the systematic sampling, right? What about next? Cluster sampling. Okay, let's say you will have to collect the regional data. Let's say you will have to, let's say in India there are a lot of states. Okay, so I can, what I can do is I can collect the data from the states. Okay, let's say I have to collect the 100 persons data, 100 persons data from each state. Maharashtra, Delhi, you know then Rajasthan, Madhya Pradesh, right? So we can collect the 100% data from each state. That is nothing but cluster sampling, right? Likewise, you will find that the lot of samplings method are there, right? Then what about next? Confidence interval. Okay, let's say I am saying that the average, you know, the average, uh, the height of Indians is, let's say 177, okay, centimeters, 177 centimeters, right? So confidence interval are nothing but the, the same answer but in the range. So I can say the average height of person in India is between 170 centimeter to 180 centimeter, right? So this is nothing but the confidence interval, right? Instead of taking the, the average exact value, let's say 177 is the average height of Indian, you know which is nothing but 177 centimeter. Height of people in India is between 170 centimeter to 180 centimeter. This is nothing but the confidence interval. Instead of taking a single value, okay, I will be using a range of values in between, let's say 170 to 180. So that is more efficient way, right? That is more efficient way to describe this kind of things, this kind of scenario, right? India is not a small country, it's very big country, right? Okay, there are around 100 and, 150 crore people are there around now. Okay, so you will find that if I say 177 centimeter is an average height, so it might be not suitable. So that's why I can say average height is between 170 centimeter to 180 centimeter. That's it. Okay, so that is the confidence interval. Now last thing, this is the last, guys. Then hypothesis testing. Okay, if I talk about the hypothesis testing, so I can simply say hypothesis testing is a, statistical method used to make inferences about a population based on a sample of your data. Okay, you are making claims on the population by using a sample. You just collected a 10% data, and in your organization there are 100 persons. Okay, 100 employees are there, and you just collected a 10 employees data, and now you are saying that, now now you are saying that, okay, okay, on the basis of 10 employees data, you are just making the claims on your overall employees. Okay, you just take the survey of 10 employees and you are saying that the, okay, like the, this is the, the the overall, uh, about your all the employees, right? That is nothing but the hypothesis testing. Okay, so here you can see that in the hypothesis testing, two main things are there. Okay, like the null hypothesis. Okay, basically null hypothesis, that is represent the default or status quo assumptions. Okay, while the alternative hypothesis represent the researcher's claim or theory. Okay, like if you are saying, let's say one example, okay, okay, it's testing a new advertisement campaign and wants to know if it is effective. Okay, so here my null hypothesis is going to be the new campaign has no effects on sales, while my alternative hypothesis is going to be the new campaign increases sales. Okay, so here, okay, to test, okay, the final test is that the company randomly selects two groups of customer. Okay, in my test, okay, the company we can, okay, randomly select the two groups of the company, customers in one group. Okay, like the old advertisement is there. Okay, and in the other group there is new advertisement is there. Okay, and after specific period of time, okay, we'll check how much sales will come from each group. Okay, if the sales is come from the, the, let's say, the old group is high, so we can say my old advertisement is good instead of my new advertisement, right? So at that time I can select the, null hypothesis. Null hypothesis is nothing but the new campaign has no effect on sales, right? So that is the thing. So here the goal of hypothesis testing is to, is to strength of evidence against the null hypothesis and determine whether to reject or fail to reject it based on the observed data. We are making the claim, let's say company makes the claim, right? He just wanted to test a new advertisement campaign to increase his sale, right? So we can simply say that the new advertisement campaign will increase the sale. So that is my alternative hypothesis. And what will be my null hypothesis? So in that case we can simply say the, the vice versa for this alternative hypothesis. So we can say null hypothesis is the new campaign has no effects on sales, right? So that is the thing. Okay, hypothesis testing is very big concept, guys. Okay, you will find that the many more terms in that. Okay, but okay, this is just the introduction, right? This is just the introduction. If you wanted to learn more about this, okay, you can check the, the, like, our upcoming course as well. Okay, this is not the, the. So guys, that's it about the today's session. Okay, thank you guys for your support and your patience. Thank you guys, thank you very much. Bye bye.